Okay, now we're still working on factoring trinomials, but the coefficient may not be 1. Okay, so we're going to combine those last two sections. Okay, if the coefficient is not 1, this time I'm still looking for those two special numbers, but instead of multiplying to give just 4, I need them to multiply to give 4 times 3. Think about that. Really, we did that last time too, but if this is just a 1, 4 times 1, it was always just this number. So I got to be careful of that. 4 times 3. And then add to give me 8. Okay, so those numbers are 6 and 2, because 6 times 2 is 12, and 6 plus 2 is 8. So we found our numbers. Now, this time, instead of just being able to put it right in our factor, I'm going to have to rewrite this problem. And I'm just going to change that 8x to 6x plus 2x. Notice, if I added these like terms back together, it still gives me the same thing. All I did in doing this was make it be able to be factored by grouping. And by the way, if you find the right two numbers, it doesn't matter which order you put them here, it will factor. If it doesn't factor, it means, oh, you messed up on finding your numbers. If you can find the numbers, it will factor. If you cannot find the numbers and you try every combination, it's prime. Okay, so what can I factor out of these first two? A 3 and an x. Which leaves, if I factor a 3x out of this first term, it leaves just an x. If I factor a 3 and an x out of here, it leaves the 2. Plus sign in the middle, so no worries. Okay, these both have a common factor of 2. If I factor a 2 out of 2x, it leaves the x. If I factor a 2 out of 4, it just leaves 2. Now, the x plus 2 is what they have in common, so I can factor that out, and it leaves the 3x plus 2. And just like always, you can check this factoring by multiplying it out. Okay? But that's it. But I got to be good at doing that. Okay? I got to be able to get these combination of numbers. So let's practice that a bit. Okay. It's a trinomial. Anytime it's a trinomial, I'm looking for numbers. Okay? Two numbers that when I multiply them, give me 1 times 3. And when I add them, give me -4. All right, so the only numbers that multiply to give 3 are 3 and 1. But if I add them, I get 4. So right numbers, wrong signs. -3, -1. Perfect. But if my leading coefficient is not 1, I have to rewrite the problem. -3p minus 1p instead of -4p. It's the same thing, but now I can factor this thing by grouping. Okay, these have a 3 and a p in common. When you factor a 3p out of this, it leaves p minus. When you factor a 3p out of here, it leaves 1. Now, careful with the 1 in front of a parenthesis. I'm really factoring out -1. We're just going to change my signs. If I take this -1 out, the p is left. If I take a -1 out of a +1, or divide +1 by -1, it leaves -1. Oh, now they both have a p minus 1, so I can factor that out, and what's left is 3p minus 1. Okay. Practice, 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 right? Okay, it's a trinomial, so I'm looking for those two numbers that multiply to give me -3 times 12. Remember, the sign in front of the number is part of the number. And add to give me -16. So I might think, well, -6 times 6 is 36, but -6 plus 6 is 0, so that's not them. Okay, what I have 12 and 3, so -12 and 3, but that's -9, so that's not the numbers I need. Let's see, what else do I have? 9 times 4, but -9 plus 4 is -5. That's not my numbers. Okay, well, what about 36 and 1? Don't forget that one when I'm really struggling and looking for numbers. -35, that's not my numbers. Let's go up and see if I've gotten all of my factors. Okay, so let's start with 1 and 36, 2. Does 2 go in? Oh yeah, 2 goes into that. Hey, and look. So don't decide it's prime too quickly. Make sure you check and make sure you've got every factor that went in there. If I had already used the 2, then I'd ask myself, does 3 go into it? Does 4 go into it? Does 5? Does 6? Right? And we found the numbers we need, so we're going to rewrite it. 12z squared. Now I can put these in any order. So just to avoid that confusion with the negative in the middle, I'm going to put it first. -18z plus 2z minus 3. Then we're going to factor by grouping. These both have a 6 and a z in common. And that leaves, when I factor a 6z out of here, it leaves 2z. Got a minus sign. When I factor a 6z out of here, it just leaves the 3. Got a plus sign, so no worries. Oh, these don't have anything in common. So when there's nothing else, there's always a 1. And a 1 doesn't change anything. Oh, perfect. That 2z minus 3 can be factored out. And that leaves 6z plus 1. Perfect. Let's do it again. Okay. I need two numbers that multiply and give what? 8 times -5, -40. And add to give what? -6. Okay, let's start thinking of numbers that multiply to give -40. How about 10 and -4? 10 minus 4 is 6. Right numbers, wrong signs. -10 and 4. Found my numbers. So let's just rewrite this. Minus 10 RT, right? Be careful. Plus 4 RT minus 5t squared, right? I'm just changing the -6 RT to minus 10 RT plus 4 RT. And then I can factor it by grouping. Okay, so they have a common factor of 2 and they both have an R. What's left is 4R minus 5t. Plus sign, so no worries. Only a 1, but they both have a t, so I can take that t out. So what's left is 4R minus 5t. Now, this is the common factor, so it can come out. And what's left is 2R plus t. All right. Don't forget our most important first step. Always look for a common factor, right? If we just went over here and started looking for numbers that multiply to give 6 times 9 and add to give to 21, we'd be all messed up. So don't forget that. I should have been saying it just to remind us every time. I'll try to remember to say that just to remind you until you get used to thinking about it. So they all have a factor of 3. Okay, another reminder for you is if you get a big number over here and you're like, oh, do they have a common factor? Can I make my number smaller? Not guaranteed you can, but maybe that means, oh yeah, I missed something. So I can factor out a 3 and a p squared. Okay, that's another clue, right? These all had p's in them. So that leaves 2p squared plus 7p plus 3. So now look how much easier the numbers are going to be to find. I need numbers that multiply not to give 9 times 6 is 54, but just to give 3 times 2, 6, and add to give 7. Oh, that's 6 and 1, right? That's 6 and 1. So I come over here, don't forget this factor. That's a factor you already found. So it's just going to come down with us forever. And then I'm going to rewrite this as 2p squared plus 6p plus 1p plus 3 instead of 7p. Now I'm going to factor by grouping. So this factor just keeps coming with us. We already found that one. I'm looking for some more. I can factor a 2p out here. Okay. And then that leaves maybe I might even, just because I know I'm going to add some more parentheses in there, if it helps you, so you don't have just a bunch of parentheses, make this one a bracket. Okay. Don't have to, but it's confusing if there's lots of parentheses inside each other. If I take out a 2p, all that's left is a p. Take out a 2p, there's a 3. Plus sign, so no worries. No common factor, that means there's a 1 if there's nothing else, and 1 doesn't change anything, so it'll just leave the p plus 3. Now, this is a common factor. So I'm taking it out with this other one that I already found, right? Here's a common factor I found, and now I found another one, and then that leaves 2p plus 1. Okay. Look for a common factor, 19 and 6, and there's not a p here, so it just takes a minute to look for a common factor. I need two numbers that multiply and give 60, 10 times 6, and add to give 19. So let's see, I got 6 and 10, which is 16. That's not it, okay? But I'm pretty close, okay? Let's kind of think about how we're going to come up with these numbers. Now that we know what we're doing, let's practice working on getting these numbers. I'm pretty close to the number I need, so I don't want to change these by very much. I'm wondering if maybe 4 goes into 60. Oh yes, it does. 4 and 15, and look at that, 19. Okay, take some practice. All right, so rewrite the problem. 6p squared plus 4p plus 15p plus 10, and then factor by grouping. You can factor out a 2p here, and it leaves 3p plus 2, plus sign, so no worries. You can factor out a 5 here, and it leaves 3p plus 2. Now the 3p plus 2 can factor out, and it leaves the other factor as 2p plus 5. Okay, I'm going to look for a common factor because, for one thing, look how big those numbers are going to be. But 10 and 23 don't have anything in common, so no luck. All right, I need two numbers that multiply to give 10 times 12, which is 120, and add to give negative 23. Okay. Hopefully, anytime a number ends in 0, you automatically know that 10 is a factor. But if you can't, if your number's kind of big and you're like, what are the factors of 120? Don't forget you got that number by multiplying by two numbers. So you always have a place to start. Okay, so 10 and 12, when I add them together, 10 plus 12 is 22. So I'm really, really close to the number I need. Really, really close. Now, here's one thing we can do. You could play with it a little bit, but another option is let's change this to 5 times 2 times 3 times 4 maybe. Right? Or maybe, if we're good, even 3 times 2 times 2, all of our factors. Let's just see all of our factors, right? Our prime factorization. Okay, so there's the 10, and then 2 times 2 times 3, that's 12. I'm just breaking this down. There's 10, there's 12. And then I can play with all of this. I can play with all of this. I notice here's another option. I could make this 8 times 15, 5 and 3. That's two more numbers that multiply to give 120. But look, they add to give 23. Right numbers, wrong signs. So once again, it's a matter of practicing this and just getting used to this idea. So once you find your numbers, it's finding those numbers that's hard. Once we find our numbers, by now, hopefully, we are set to go. We just rewrite the problem and factor it by grouping. Okay, I can factor out what? A 2m. That's going to leave 5m minus 4. Minus sign, so be careful. I'm taking out a minus 3. So that's going to leave 5m minus 4. These signs must change, which is perfect because they both have a 5m minus 4 now and a 2m minus 3 as the other factor. Okay, no common factor here. So I'm still just looking for those numbers that multiply to give negative 60. Negative 60. Don't miss your signs, and add to give 11. Well, okay, how about negative 10 and 6? No, that's not it. So let's practice that method we talked about last time. So 10 I can rewrite as 5 times 2, right? And 6 I can rewrite as 3 times 2. So now I can see all my different combinations. I've got 10 and 6. I've got 4 and 15. I've got, well, 15 and 4. I don't have that many combinations here. But one of them I see is 15 and 4. So negative 15 and 4. Hey, negative 11. Right numbers, wrong signs. I need positive 15 and negative 4. Woohoo! Once we get to that point, we've got it done. We just rewrite the problem, and I'm going to put the minus in the middle. If I don't, I have to be really careful with that sign. And then factor by grouping. Okay, I can factor out a 2m here. And that leaves a 3m minus 2n plus sign, so no worries. I can factor out a 5n, and that leaves 3m minus 2n. So the 3m minus 2n can come out and leave 2m plus 5n, and voila, we got it. Okay, just a couple more. Don't forget greatest common factor, first step always, okay? We don't mention it every time, but we do visually check that. So greatest common factor, these are all at least even, maybe a bigger number, but I'm going to start with a 2, and I can take out an x squared. So if I factor a 2 out of 28, that's 14x squared. 58 divided by 2 is what? 29x, and then minus 15. So 2 was the biggest number. I can see there's no common factors. All right. It made my numbers a little bit smaller, but not a whole lot. I need two numbers that multiply to give whatever 15 times 14 is, and it's negative. Can I just put it like this if I don't know what those are right away? Because I'm going to break it down into factors anyhow. And add to give negative 29. Okay, so remember, I got this number, whatever number that is, from 14 times 15. Oh, but that's a 1, so that's not my numbers. But now I can look at different combinations of this. That's 7 times 2, and that's 5 times 3. Is there any way I can combine these and get 29? Well, there's a 10 and 21. 10 and 21, that's not 29. There's a 6 and 35. 6 and 35. Because one of them is negative, right? Negative 35 and 6 gives me negative 29. It just takes practice, guys. Hopefully this makes sense. Let me know if not. Now, once I figure that out, I just gotta rewrite my problem. And I'm gonna put the minus first so I don't have to worry about that. Okay, and then factor by grouping. So those first two terms have a 7x in common. And again, maybe it'd be less confusing for us if when we had a greatest common factor, we used a bracket for that first parenthesis. So now I can factor out a 7x. Okay, that leaves 2x minus 5. Plus sign, so no worries. I can factor out a 3. And that leaves 2x minus 5. Now the 2x minus 5 is in common, so that can come out here with this other one that I already found. And it leaves 7x plus 3 in those brackets. All right, one more time. One more time for me, then y'all can go do a whole bunch, right? Okay, greatest common factor, even if it didn't, I want that negative out of here. Negative to the front, so I know that, even if there's nothing else. But I see, a 2 probably, at least. And they all have an x. Okay, let's try to remember if I have a greatest common factor. Let's just go ahead and make it a bracket. Okay, so that's going to be now a positive 12x squared, a minus 16xy, and a minus 3y squared. Notice they're both squared, and I have an x and a y in the middle. So that's fine. It's going to work out. I need to find two numbers that multiply and give me negative 36, but add to give me negative 16. Okay, so again, my first thought is negative 6 times 6, but that's 0. But once I get a couple of factors, and I could have done 12 and 3, right? Right here, 12 and 3. But once I get a couple of factors, I can change that to 2 times 3 times 2 times 3. Now, one of them's got to be negative. Okay, so I can see all of my different options. There's the 6 times 6, right? There's 6 times 2. There's the 12 times 3. Okay, if I put these three together, that's 18 and, 18 and 2, right? That's what I need. So I need to use negative 18 and positive 2. Perfect. And then just rewrite your problem and we're good to go. 12x squared minus 18x plus 2x minus 3y squared. Oh, don't forget these are xy, xy. Don't forget that. And then factor by grouping. Minus 2x. Okay. Now out of these two terms, I can factor out a 6x. That's going to leave 2x minus 3y. Plus sign, so no worries. And here I can factor out the y, and that's going to leave 2x minus 3y, which is now another common factor. So bring it out to the front with the other factor you found in the beginning. Okay, guys. Good luck. Let me know what you need.